Today in pre-cal we learned about complex numbers. We're going to start with some definitions and some general information about these complex numbers so that we can have a basis with which to speak together about these topics. The first thing is that the imaginary unit, which is called I is equal to the square root of -1. So the imaginary unit is I. What I means is anytime there's a square root of a negative number, a square root of -1, that is I. Standard form of a complex number is A plus BI. And what that means is A is your real numbers, just normal numbers, things you're used to looking at, and BI is your complex numbers and their coefficients. I has a special power, and that is that it is very cyclical, which means it follows a pattern that rotates over and over again. It rotates every 4. So if I have I to the first, I to the second, I to the third, I to the fourth, and I think about it like I won the lottery, I can remember I won. And write that down on my paper. The middle two are negative. If I can remember this pattern, I can find I to any power because I can take out multiples of 4. We'll practice that here in just a second. But for now, you should know that you'll need to memorize this right here. Let's look at a couple of examples of this. Example number 1. What is I to the 9th power? The first thing I want to do here is figure out, are there any multiples of 4 within I to the 9th? Well, 4 does not go into 9 evenly, so let's take that down one exponent. Let's try I to the 8th. 8 is divisible by 4 2 times, although the number of times does not matter. So I can take out I to the 8th and multiply that times I to the 1st, because 8 plus 1 is 9. These two things are equivalent. I to the 8th is a multiple of I to the 4th, which is 1. 1 times anything is itself, so any multiples of 4 go away, and my answer to what is I to the 9th is the same as I. Let's look at another example, number 2. What if I wanted to do I to the 84th? And this would be a good answer to why can't I just count? Some people today wanted to say, well, I to the 9th I could just do 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's I. And you're absolutely right, that would work, but I would not suggest counting this 84 times. Instead, does 4 go into 84? Yes, it does. So if 4 goes into 84, the answer is just 1 if it goes in a perfect amount of time. Let's do one more like that. What is I to the 82nd? Well, we know that 4 doesn't go into 82. We know that 4 doesn't go into 81. We'll check, does 4 go into 80? Yes, it does. So I can take out the 80, put what's remaining, which is I squared. 80 is divisible by 4, so that part goes away. And I squared is equal to -1. So my answer is -1. That's part 1. Part B, let's look at how to simplify some square roots. This will become particularly important when we're using the quadratic formula to solve for our solutions or our zeros. This is example number 4. The square root of -9. Previously, we've not been able to tell the square root of a negative number. Now we can by doing -1 times the square root of 9. That's equivalent. We know that the square root of -1 is I, so I square roots of 9. And we know that the square root of 9 is 3. So the answer here is 3I. And I'm basically just breaking that down to get an answer. Let's try another one that does not simplify exactly, like the square root of -84. That would be the square root of -1 times the square root of 84. You can bring out my I. And then what two things multiply together to get 84 and also have a perfect square? That would be something like 4 times 21. Remember, the numbers that are valuable to be able to multiply by are like 4, 9, 16, 25, etc., because those are perfect squares. And we know that the square root of 4 is 2, so I have 2I square roots of 21. Nothing goes into the square root of 21 to make that come out evenly, so I can leave that exactly like it is. Part C for today is learning how to add and subtract. So we're going to do adding and subtracting of complex numbers. This is the last thing for today. Example number 6. If I have 4 plus 7I plus 1 minus 6I. In this problem, I have parentheses that don't do anything because I can't combine these. They're not like terms. Same thing going on here. The positive in between doesn't change anything, so I'll just add my like terms. 4 and 1 make 5. 7I and -6I make positive I. And Notice I've written my answer in the form a plus bi. Got a few more examples like this. Let's try one that's subtracting. If I have 1 plus 2i minus 4 plus 2i, I have a minus in between my parentheses, so I've got to distribute that negative. So 1 plus 2i minus 4 minus 2i. Notice I've distributed the negative here. Now I want to combine my like terms. 1 and negative 4 makes negative 3. 2i and negative 2i will cancel each other. And that means that negative 3 is my final answer. What happens if I have multiple groups, such as 3i minus negative 2 plus 3i minus 2 plus 5i? If that happens, I want to distribute the negative in front of the parentheses. That's very important. So I could write this as 3i plus 2 minus 3i minus 2 minus 5i. You should be seeing that some of these things are like and opposite, and so they cancel. And my final answer to that one is negative 5i. Notice that there is no real part to that solution. In this one, there was no imaginary part to that solution, and in this one, there was both, which is why we wrote it in a plus bi, or standard form. Let's try one last example that you might come across in your homework. Negative 12 minus the square root of negative 15 plus negative 5 plus the square root of negative 15. This time, I don't have any I terms, but I do have negatives under square root. My first step will be to simplify those pieces. So I have negative 12 minus, and a negative 1 times a positive 15 is negative 15. So I take out my I square roots of 15, plus negative 5 plus I square roots of 15, for the same reason here. You'll notice that your I square roots of 15 cancel, and I have negative 12 and negative 5, which makes negative 17. And once again, all of my imaginary pieces went away. Sometimes in your homework you may be given two different square roots. You'll need to simplify those if you can to be able to combine like terms. Your assignment here is A9, and that's page 167, numbers 5 to 9 and 17 to 26. If you have questions, be sure to let me know or come to tutorials.